Hello again, this is a geometry video, and our topic is distance formula. And I'm going to use some coordinates on the coordinate plane here in order to show you one technique that, I think is easy, and an easy way to remember the distance formula, but you need to know Pythagorean theorem. So let's plot some points. Let's put one in quadrant 1. How about 2, 5, and then let's put a point in quadrant 2. Let's make it -5, -1. Just picking some random points. And so this is the distance, and what I'll do is I'll construct a segment to show you that that's the distance we're looking for. Now, certainly this is a formula you should know. And this is commonly how it's written. Lowercase d, distance, is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, if you're confused about these subscripts, the x2 and the x1, that just means that if we're going to call this point 1 or this point 1, it doesn't really matter. This is x1, y1, the coordinates for that point. And this is therefore going to be point 2. So this is x2, y2. So what do we really have here? For this point we chose, I think, 2, 5. Now I'm writing the comma here. There really is a comma here also, but I didn't want you to get confused and think that was a number 1 or something. So 2 is my x2 value, 5 is my y2 value, and then we chose -5 for this x value, so that's x1, comma, and my y1 value is -1. Did I say we were going to be in quadrant 3? I think I said quadrant 2. Oh well, we're in quadrant 3. And so then you could substitute -5 in for x1 right here. Subtract that from x2, which is +2. Square that quantity, add it with y2, which is 5. And then from 5 we will subtract -1. Square that quantity, add it with this other quantity, and take the square root. So we've gotten this far. Let's finish this. This gives me +7 squared, which is 49. And this gives me +6 squared, which is 36. And then we get the square root of 49 plus 36, square root of 85. Analyzing some other time. Alright, now, this isn't the preferred method. Come on. There we go. For me, what I like to do, we'll be doing the same math, but I like to think of this as a right triangle. And I think this is a pretty good way to look at distance problems. And now you can see we have legs of a right triangle. Well, this is much easier to calculate because it's on a perfect vertical. So what is this length right here? We can just sort of count the spaces, right? 1, 2, 3, 4, 5, 6. Distance is always positive, so one leg has a length 6. And now let's count these. 1, 3, 4, 5, 6, 7. 7. Now, if we want our hypotenuse, Pythagorean theorem says 6 squared plus 7 squared equals c squared. And can you see the distance formula is going to be showing up here? To get c, we take the square root, and because distance is always positive, we take the principal root, and we get 36 plus 49 under a square root equals c, which is square root of 85. And I think that's an easier way to calculate distance, and you don't have to remember the distance formula, but this certainly will help you derive it if you forgot. Thanks.